right, good morning, everyone. Thank you all for coming to MITRE this morning. We are here for NTIA's listening session for AI native networks. To kick us off this morning, I would like to welcome Tricia Paletta from NTIA. She is a newly arrived senior advisor to our office. She's going to provide opening remarks.
Thank you, Amanda, and thank you all for coming out here on this morning, this Monday morning, and thanks to those of you online. We really do appreciate your participation in this event because, well, certainly for me, as Amanda said, I am newly arrived, so I'm definitely in listening mode and want to hear from the industry, from the innovators out there, how best to use this last tranche of money we have under the Innovation Fund, the program of which Amanda is the director. And so it's very informative for certainly me and of course the rest of the team. And of course this listening session alone is the culmination of a lot of their work. So I'm very appreciative of all the work they've done in the past. So as Amanda noted, we're very excited to discuss the prospects of AI native radio access networks, or RAN, and using the Innovation Fund dollars remaining to us to drive their development. This session is, it's been long in coming, but we're not ready to issue this NOFO without, again, hearing from industry and then having your experience of what's actually developing out there, what's possible to shape the final NOFO that we will issue after we incorporate your remarks. As we all know, AI is a transformative technology that is, among many other uses, shaping how wireless networks are designed, operated, and monitored. And it's an area in which America leads. This fund represents a strategic opportunity for the United States. By leading the design and deployment of AI native network infrastructure and services, the U.S. can strengthen its global communications position, drive economic growth, and secure long-term technological leadership. Under President Trump's AI Action Plan, this administration is harnessing the full power of the federal government to set the conditions in which private sector, American-led AI can flourish. NTIA believes we must be proactive in the race for next-generation networks. Ensuring the widespread adoption of a trusted 6G stack is foundational to achieving America's vision of a free and decentralized internet, one built on secure, resilient, and trusted architecture. In support of that vision, NTIA's Innovation Fund is focused on promoting US-based AI native network infrastructure. This effort aligns with both the AI Action Plan and the President's executive order on promoting the export of the American AI technology stack, and of course also his memo on winning the race to 6G, in order to reinforce Innovations Fund broader strategic objective in this year, in this current environment. Our hope is that by issuing a new Notice of Funding Opportunity, or NOFO, for the fund, NTIA will enable an early competitive edge to America's innovators, foster collaboration among trusted RAN vendors, cloud providers, and service and app developers to accelerate the development of a secure AI-native telecommunications architecture led by U.S. industry. So today, our team will engage with you in a discussion on AI-native architecture to better understand the promise of this technology and how the federal government can help move forward the state-of-the-art. We look forward to hearing from hopefully from all of you, if not now, at another point. And thank you in advance for your contributions. Okay, Amanda, it's back to you.
All right, Tricia, thank you very much for those remarks. So again, I'd like to welcome everybody here today. The point of today is a listening session, right? So we gathered everybody here, and I know it was relatively short notice, so thank you all for those of you that are in the room and those of you that made time to attend online. It's really important for us to gather your input to make sure that whatever we incorporate into the NOFO is considered all of your input so we can really put out the best notice of funding we possibly can. So we're excited to hear your thoughts about AI native network architectures. We think we are at a point in time where there's a, dare I say, an inflection point in technology. We're gearing up towards 6G, but we also have AI becoming prolific, right? And the opportunity, we see it for U.S. to regain leadership back in the telecommunications space by trying to merge telecommunications with IT communications really provides an opportunity not just for U.S. innovation, but an opportunity to really transform and revolutionize the network. So we think by doing this and doing so in a more of an expeditious fashion will enable U.S. innovation to flourish, really trying to drive and harness the unique capabilities we have here in the U.S. And provide opportunities for some of these smaller players to get into this ecosystem, really harness the capabilities that we think are possible in future networks and future technologies. So, really interested in your thoughts around those topics. How do we move on from what we've done in 5G? We don't necessarily want to repeat and have 5G plus, really working towards that revolution, not just an evolution in networks. So in terms of today, I just want to lay out some sort of ground rules. As we've said, this is a listening session, right? So we are here to gather your inputs and your thoughts. This is not an opportunity for my team and I to answer your questions. I will say, obviously, we are going to be drafting a NOFO, and when we publish and release that, we will have likely another similar session where we will answer questions and get your thoughts there. But today, the whole premise is around gathering your input, and we're listening to you. So we have today structured with 5 general topics. We've allotted 30 minutes for each of those topics, and we will allow you to provide your thoughts on those topics up to 5 minutes. I have my technical team who is going to help me deliver those topic areas. We will monitor and make sure that folks align to the 5-minute mark. So there are a lot of you in this room, and I'm sure there are many more online. So we want to be sure that we give everybody that wants to provide their input an opportunity to do so. I think with that, I am going to ask my technical team to come up on stage. So I've got Brad Hunt, Larson Harden, Manu Gosain. They are going to be helping me moderate the specific topics. All right, and first up, so Brad, you don't have to actually get too comfortable because I think you are first on the stage. Right. So I'm going to hand it over to Brad to lead us on our first topic area.
Hello, good morning. Can you hear me okay? Okay, are we advancing these? Go. Okay, I have a pretty easy one. Topic number 1 is the role for artificial intelligence for wireless telecommunications networks. Broad topic, interested in your perspectives or your point of view.
So for those of you in the room, we have microphones set up in the aisle. So if you want to queue in front of the microphones, happy to take your comments, or folks online, I think, can enter into the Q&A or raise their hand to provide remarks.
I don't see any reason.
I'm going to go back to the agenda.
Go through those.
There we go. Thank you.
So we've got AI and wireless, AI's impact on telecom and 6G, network architecture for AI, U.S. AI leadership and wireless innovation, and AI-enabled network data monetization and sharing. And first topic is AI in wireless networks.
I think we're not going to
say, I don't know still if I'm on, I don't think we're going to limit people to 5 minutes over the total time. You know, if you got inputs in, you know, try not to have a 5-minute input in every question in the process, but don't worry that if you've spent 3 minutes over here and 3 minutes over here, you don't get to talk anymore.
Correct. All right. Thank you, Jim.
No problem. I probably want to talk about a lot of these topics, so hopefully I won't cover it all in the first one here. But I think AI and wireless networks is critical, especially for U.S. leadership. You know, I think most of you know about the AI RAN Alliance. I think you know about the Okudu contract. There's a lot of ways we're going to be able to put AI into the network. And we see AI at many locations. I think one thing, you know, DeepSig and other people have really been pushing is actually using AI to replace traditional signal processing. And with that, you know, we're seeing significant improvements in performance. And as you know, part of AI generates a lot of workloads from sensors back to the network. So what we need to do is make our wireless networks very able to accommodate this uplink performance. And I think AI is a way of doing this. Then we have the whole issue of, you know, we have a heterogeneous network. We have various frequency bands that we're operating at. We have Wi-Fi, other modes. And I think AI can really help the orchestration between all these different aspects. You want to be able to give the best user experience for the quality that's required. And that varies depending on what the application is. You know, if someone's just using their computer browsing the internet, that's a different latency requirement than, for example, self-driving cars, voice interactions. So AI there is playing a critical role. And I think in another area is you can use AI in the wireless network as a sensor capability. And we've all heard of ISAC, Integrated Sensing and Communications. So we see it's critical to go add AI on that location to add new markets and new capabilities, both for the defense of the United States and develop commercial markets for you know, our wireless carriers. As you know, wireless carriers, 5G for many of them was not a great economic boon. And we need to go figure out how to grow the market so all boats get lifted in this market. And we think by making open standards that small businesses with innovative ideas can employ AI to really be able to put this in the network and find new markets. So with that, I'll finish for now, but probably be up here for some of the other questions. Thank you so much.
I'm sorry, before you sit down, when you all come up, can you introduce your organization?
Sure. Jim Shea, I'm the CEO of DeepSig.
Hi, Hongwei Zhang from Iowa State University. I guess, you know, role of AI in wireless has been discussed for a long time, and there has been a lot of progress in both research and also trials, right? I think now it's about time to look at actual deployment and adoption. Along those lines, I think it would be good for us to look at the specific use cases at different time scales. For example, from some of the shorter timescale use cases of radio resource allocation to really long timescale use cases that's going to drive adoption, for example, capacity planning, deployment planning. I think that can be even used by small operators who don't know how AI works, right? So as we look at this new phase of program, this could be one area we can probably drive progress from ideas to actual deployment and operations. Thank you.
I am Durga Sarapathy, ex-T-Mobile independent consultant now. I'm also going to talk about the AI RAN Alliance, having spent a lot of time with them. While the topic is role of AI for wireless networks, immediately makes you think of using AI to improve performance of the networks, of operators, and thereby getting the benefits for the consumers too. I think the NOFO should look at not just that part, but also the couple of the other thrusts of the alliance, which is to say, how do you do both AI inferencing and RAN performance over the same operator network? So this may be touching a little bit on the other topic of architectures, but essentially, how do we enable our operators to be able to launch infrastructures that are capable of being physically AI native and everything 6G and beyond, not doing just RAN, but also the AI aspect. So the AI workload and RAN workload orchestration, how can that be done optimally together? That should be an ask from the NOFO to have the innovators come in with new ideas, new ways for the orchestrators to run that balances both of these. And making a reference to the AI grid that you must have heard from the GTC, The AI grid could then be viewed as not just a single operator's network, but a federated system where you have multiple operator networks all working in sync together, control plane across all of them with cooperation, of course. So that's another area we could think about. And finally, as we look at new use cases and applications, video has been a big thing for ages. MEC didn't work out very well in the last decade, but now it would with 6G coming in, connectivity is out there, AI is out there with all the compute and everything else. I think the novel use cases that are coming out should also be a focus, like what should the operators design the networks for? What should the vendors actually try to provide in terms of KPIs for these use cases to take off? Is it robotics, physical AI, all these terms, right? So those are the three areas I think we should be thinking about. Thank you.
Thank you.
Thank you. Chaitali Sengupta, CEO of Cirrus 360. We are a small company in the Dallas area. One of the areas I'd like to bring everybody's attention to is, we are talking about new use cases, new verticals. AI actually, in a way, opens up a lot more possibilities than we had before, where basically 5G or 4G, we are doing one thing. Now we really want to do many different things with a network, which makes the whole system integration and validation problem much more complex. So one area to think about is how does AI help put these systems together? Like the large OEMs, they have hundreds and thousands of engineers that they throw at this problem. Instead of that, how do we automate it? How do we apply, all the new possibilities that AI has brought up in all areas of the CI/CD pipeline, from design to validation and deployment and monitoring? Thank you.
Thank you.
Thank you. Hi, Eric Berger, Virginia Tech. And that's why I keep coming back to the agenda. So if this is not the right place, you're taking the note anyway. So just as we're concerned that like LLM and AI is going to take all the power, all the water, all the land, I've seen a number of projections that say by both having AI run the network and AI applications on the network, we're going to use all the bandwidth. So a thing to consider for the NOFO is looking at maybe how we can use AI to reduce the amounts of bits going over the network so that, in fact, we don't collapse our networks or we don't need all the spectrum for 6G. Thanks.
Thank you.
Hi, Tracy Van Brackel, WinLab, Rutgers University. So most of the time when I hear AI native 6G, it's also AI native, secure by design, resilient by design. Now, what that means is AI, it can be RAN centric, but it has to take into consideration, and others have touched upon this, it's got to be multi-domain. It's got to know something about transport and core, in some cases multi-operator. So I understand that the focus is RAN, but I hope there's interest in AI, more multi-domain, multi-subnet, multi-operator. Thank you.
Thank you.
Good morning. Kyle Allen, Airspan Networks. Just two things I think input from our perspective would be AI enables telecom to go beyond connectivity, so to broaden just beyond providing connectivity. I think some of those things are already mentioned, whether that's integrated sensing, mesh concepts, and also PNT, so positioning, navigation, timing. All of those things I think the NOFO should consider. And then also beyond terrestrial. So, non-terrestrial, whether that's drones, commercial aviation, HAPS, satellite, LEO. I think AI opens up some amazing opportunities in both of those spaces. So I would encourage you guys to think through that.
Thank you.
See if this has any prayer of picking me up, right? You can take the mic. You guys can hear me anyway, right?
Yes.
So Bob Everson with Cisco. Thanks for the opportunity. I just have to say this is the perfect timing for this and for this shift, because as AI is moving from heavy predominant focus on centralized training to now distributed inference and how we get these workloads actually operational out there in the network, this is the perfect time for US leadership, building off of that foundation for the entire network stack. So if we look at, AI RAN, obviously AI RAN offers some tremendous innovations. I think other people have kind of focused on what we can do there. Really essential. But in the end, AI RAN is another inferencing application that runs on these networks. Yeah. So we think one of the focuses of this is how do we build out that substrate? How do we build out that infrastructure and get commercially viable use cases and revenue for our operators in the process? Because one of the things they've been really clear with is, Isaac and all these technologies are really cool, but who's going to pay for them and what's going to fund this? And so we think there's a tremendous opportunity for this. Somebody referenced AI Grid earlier. Obviously we launched that. Now's the time, though, over the next year or two, where we can really drive this domestically and then have that stack that we can export and assert that U.S. leadership. So, thanks.
Thank you.
George Woodward, CEO, Trilogy Networks. Much of this has been kind of mentioned or at least touched upon, applications and use cases. I want to make sure that I do a shameless plug for digital agriculture. We see AI wireless as a perfect application to deploy across all 900 million acres of U.S. farm and ranch land. Food security, national security, there's a lot to be said there, and I'm hoping that NTIA includes that in the NOFO opportunity. Thanks.
Apurva Modi. I'm the founder and CEO of Aeronaculus. It's a Boston-based startup. Our aim is to make all the networks resilient to interference and congestions and make it AI-enabled. I've spent all my life in spectrum efficiency, from white spaces to dynamic spectrum access. One of the things that I have been thinking about, especially for AI for wireless telecom networks, is that you see all the conflicts going on, and we were at Mobile World Congress, and a lot of people from the Middle East came to us and said, like, our GPS is being jammed. And all these 5G networks are being driven by GPS. If you don't have GPS, they don't really run. So in order for you to actually make these networks run, you have to have that entire infrastructure which is resilient, and especially in terms of the cybersecurity as well. I mean, ORAN, for example, has got so many different interfaces, right? And they all have to be secured. And you might have, like, for example, RIC in the cloud, and you might have some other components which are close to the RAN. And how do you actually secure everything? How do you make everything resilient to interference and congestion? Even slight amount of interference, like precision timing protocol, PTP, like interference or RF anomaly actually can completely disrupt the network, and it can massively reduce the amount of capacity that you can have. So resilient wireless infrastructure, that's what we're looking for.
Thank you.
Good morning. I'm Jen Congdon from Booz Allen. One of the things I think that, as far as roles are considered, and the gentleman right before kind of started hinting at it, from resiliency and trust and security, we have a lot of ability to reimagine the way we do continuous monitoring for security. The AI can really accelerate us going through that. So the ability to bring agentic AI into this architecture, which I know is one of the other areas, but I think AI can be an accelerator for the telecom networks to be able to reduce the impacts of the broader attack surface itself, as well as the sophisticated actors that we can see having opportunities different than what we expected, 5 and 7 years ago. So I think that part of AI, you call, I don't want to say the low-hanging fruit, but there's a lot that can be done. Once you get in, there's so much activity that can happen on a network. So I think really using that AI activity, or the, what's the role, is helping to apply AI into the security network itself, and then help us to get through hardening faster, as well as, whether it's different applications doing, what different applications that are interacting. If something's going on that is anomalous, that you can detect that faster and earlier with limited manual intervention, because I think those seconds are going to be really impactful for us as we move forward in the AI era. Thanks.
I think most of us will exhaust in the first session itself. My name is Kalyan Sundar. I'm from Keysight Technologies. A lot of our industry peers here talked about the value of AI, and we see the same thing in the telecom networks as part of AI RAN Alliance. Keysight has been participating with multiple industry peers here on many experiments, and as some of them have alluded to, we are seeing very good promise. The question is, taking it from an experimental phase into deployability, very similar to how NTIA helped the industry in NOFO 1 and NOFO 2. I think NTIA can play a very good role in terms of how do you take these models that seem to be holding so much promise for telecom networks in terms of uplink speed up or better compression algorithms or reducing the number of bits that go in there or whatever it be. It's going to take work, and that's where NTIA could pull the industry together in terms of how do you let these models be trained and ready for deployment. So my pitch here, or rather, this is real. It's coming very fast at us, but in order to take it from a phase of prototype experimentation into deployability, I think NTIA can play a very big role.
Hi, Eric Luther, Software Radio Systems. I think one of the most exciting things that we're seeing in the advent of AI is that the RAN stack is now software, and it can be innovated on at the speed of software. And so as we enhance the RAN, we can now build these things, we can now deploy them, and we can put them in the field at about as fast as we can think of them. And so the next step, I think, is really figuring out what are the KPIs that we're going to optimize for. How are we going to measure that this thing that we deployed was successful and maybe better than what came before it? And so I think prototyping is really the key. I think that starting to deploy that with realistic network and coverage models will be increasingly important, and being able to evaluate how these models perform in closer and closer to real world scenarios is both possible, but also requires collaboration in spectrum, collaboration in radio providers, collaboration with handsets. And so that level of coordination to actually validate AI, in my opinion, is way harder than creating it in the very beginning. So I really look forward to having your support and being able to bring these things to market and validate their value, their benefits, and really establishing those KPIs.
Thank you. The last one. So far. Hey, Paul Grunwald, ODC. I also agree with a lot of the comments here. I think the last step when you start building AIs into the RAN for performance or for use cases and everything is really getting into commercialization, spending the time out in beta testing and improving your models, right? So really when you talk about things is how do we get out of our labs and get into the real world? Every AI is not going to work out of the box perfectly, and the carriers aren't going to want to spend that money to improve the models so that somebody else can take it. So really that's what we need to take a look at as well.
Thank you.
Can't believe everything's not going to work perfect the first time. First time. Ours does, yeah.
Hongwei Zhang from Iowa State again. I just want to highlight maybe one thing after hearing all this. So I think, one of the questions we can ask is actually what are we going to enable that's not feasible today, right? So with that in mind, I think there's one area that we can try to think through. For example, can we use AI to build mission-critical, safety-critical wireless networks, whether that's in defense or in factories or in farms? There are actually many such cases where you want to be able to reason about the behavior of AI, be able to predict and prove its properties. I think this could be one, both in terms of capability, barriers, and also the use cases. That would be something wonderful to see. Thank you.
Thank you.
Hi, Leland Brown from Capgemini. Just wanted to state that I used to be an RF engineer. So one of the things that was really a challenge, I don't know if it's a challenge now, I haven't been an RF engineer in a while, is predicting coverage, designing that path loss along with the clutter profile, and ensuring that the clutter profile meets the antenna that you're picking, and then the pattern of the antenna and the like, right? That was always a key aspect, and even your spurious emissions off the side lobes, like a highly affect the interference and everything. So I think for me, just being a person that understands what it is to actually design a network and then implement it, aggregate throughputs and the like. I think that's a key aspect here that, and I'm not saying that we haven't looked at it yet. I think a key source in terms of ensuring that AI really helps us to design networks. When I say design networks, design the actual coverage and the air interface that goes down to the actual customer is going to be key. So those clutter profiles, as I stated, the antenna designs, all those things are key. It's not just putting up an antenna, it's the actual right antenna, the patterns and all that stuff has to be key here. So just wanted to make that point. Thank you.
Okay, if we do not have any others here in the room, Peter, do we have any questions online or comments online for this particular topic?
We do have a few comments. One comment goes to what was spoken about earlier in regards to looking at telecom networks as critical infrastructure and using AI to help secure that. So AI being integrated with other networks, if you will, to help improve that security. Sorry, I just had another one pop in. Yeah, let me, give me a few seconds to process these, and I'll get back to you.
I'm Hariharan Krishnan from General Motors. So the current administration under President Trump has emphasized that smart manufacturing, advanced manufacturing is the priority for the United States. So we feel that AI and wireless networks play a very important role in the next generation smart manufacturing for automotive companies. There are many requirements for that. The wireless networks support what you call as the next generation autonomous mobile robots. Today, in a manufacturing plant, it's automated guidance vehicle, which goes on a specific track and very slowly. Now we have an unstructured manufacturing floor where parts have to go from station A to station B to station C and so on and so forth. We want to do it fast. We want to do it reliably with good precision. And so some of the critical aspects are like you have thousands of robots in the next, we're envisioning in a manufacturing floor, especially in automotive. And they need positioning, accurate positioning capability, being able to create a dynamic map of that area, which is always changing. People are moving, robots are moving. There's lots of things that are happening. So using, camera information and other information to dynamically create what you call as a fleet management map. So robot can go from station A to station B. That's one area. Positioning is one, and map creation, and we can use a lot of AI to do that. The second set of use cases that we're thinking about is, especially with electric vehicles, is that in manufacturing floor, when the vehicle is partially made and it's able to move, we don't have a problem with emissions because it's electric. So although it's a closed space, so it can automatically go from one area to the other. For example, from station A to station B, get the CALs loaded, go from station B to station C to do some preliminary validation testing indoor and so on and so forth. Even for that, we need accurate maps and good positioning, and latency is critical. And we also have what you call as predictive maintenance, where there's also machines, there is also parts that are being assembled, and the machines have sensors. We can use AI to learn the sensor information to predict when a machine will fail ahead of time so that the losses are minimized, the time is saved. Same thing with parts. We can minimize based on AI techniques and sensing techniques, that we can minimize the failure rate of parts that are being manufactured. And more importantly also is worker training becomes very important. Now it takes a lot of effort and time to have somebody coach a new worker who joined General Motors or another company. But we can have augmented reality techniques where with all the different glasses and all those things, people can know how to assemble parts, do their job efficiently, much faster. And these are the things we think are going to make America on the forefront of next generation manufacturing. which the government wants. And AI and wireless networks plays a critical role for that.
Thank you.
Brad, we had two comments come in, and I'm just going to generalize around the fact that these networks, especially the RAN network, is becoming ever so more complex when you think of the technologies, the signal processing algorithms that are used at the edge. Can AI be used to help address that complexity and make interoperability or integration between different components within the RAN and the core? Can AI be used to make that process a little bit easier?
Okay, great. Thank you. And thank you for the manufacturing perspective on that. All of this input was very, very useful. Having spent a little bit of time on a couple manufacturing floors with some autonomous robots, I always felt a little more comfortable standing in front of the little ones than the big ones, even though I know it's a consistent technology. Okay, very good then. If there are no other comments on this one, let's move on to our next one. I think it's you, right, Mom?
Yes, sir. So the next topic, if we can go next slide. Okay, perfect. So this is about AI-driven changes in the telecom industry and the influence on the emerging 6G technology stack. So let me just frame that before people start commenting. So this is around, 6G is going to come, people who monitor standards, 3GPP, et cetera. There's a lot of work happening in terms of different parts of the network and how AI is being looked at from the perspective of being standardized. And we also know the 6G timeline moving into the 2030 timeframe, at least with respect to the specifications being developed and matured. So here we're trying to understand what are those changes? What is the perspective of the, you all with respect to standardization around AI, and take this as a very broad aperture question, whether it's talking about models, it's talking about data, it's talking about agent deployment, orchestration, whatever it is, in the purview of what may be happening in SDOs, and I'm just not limiting it to 3GPP, broaden the aperture to the O-RAN Alliance, IETF, et cetera, et cetera. So that's sort of the the perspective that we're wanting to learn from those who are involved in these SDOs and whatever they're monitoring out in the literature.
We could get Jim to be first again.
Yeah, clearly one of the things we are seeing with the 6G stack as it's being built is it's API driven. And with API driven, what it allows you to do is it allows you to bring in AI enabled algorithms, mix and match, so to speak, very similar to what we saw with the original O-RAN intent, where you're mixing and matching different components, whether it's on the DU, RU, et cetera. The same thing we will start seeing in 6G. At least there is a lot of promise for that. Given you're building some of these stacks, you could bring in a new waveform for something like sensing. You could bring in a different scheduling algorithm. I think the APIs are going to play a major role as the 6G stack gets built.
Jim Shea with DeepSig. I think if I kind of flip this question around the other way, it's critical that we attempt to influence the 6G. Now, things are moving quickly on the releases, but standards committees can be very bureaucratic. There's a lot of political pressure. So I think as part of NTIA, we have the AI RAN Alliance, we have Okudu, we have all these different entities. I think we need to be the entities that drive AI and 6G. And I think otherwise we're going to get a standard which really, may miss the mark for what we want. There's a lot of concern about adding models and how it's done, referring to the APIs. And I think, this NTIA NOFO can be one of those items that drive, maybe hopefully the first release of 6G, but for future releases of 6G to add these capabilities that we're going to need to really make this an evolutionary network. And I mean, I'm hoping we're getting past the 5G, 6G, and now that we have a software network, this can be a gradual evolution, because it's almost impossible to figure out what's going to be the killer application or applications moving forward. And I think this NOFO can be, hopefully one of those components that drives that. And I'd encourage you that, as part of your NOFO, that it be required that however you break this up as one or multiple efforts, that there be participation in standards committees, both in, O-RAN Alliance and the 6G, 3GPP working groups. Thank you.
Doug Kirkpatrick, Aridan. I'm going to take your question from the other side. AI-driven changes in the telecom industry. I think if people were at the GTC recently in San Jose, you saw Jensen close his keynote with a whole bunch of robots on the stage talking about physical AI. I think everybody understands that the current way that our networks work are download, downlink intensive. It is widely understood that that's going to flip by more than a factor of 10, perhaps by as much as a factor of 40, to being uplink intensive. That is going to fundamentally change the way the network has to operate. This solicitation should cover something which is an end-to-end demonstration, because that change from downlink dominant to uplink dominant is a massive change in how a network operates. The second part of it is we're talking about AI-driven changes in the telecom industry. I think a lot of people have mentioned MNOs. I think that is only half of the question, because the other half of the question is going to be all of the enterprise telecoms that are going to be driven, as the gentleman mentioned, the manufacturing floor and all of the rest of those, and then the heterogeneity of combining those enterprise networks into things that are leveraging off of the MNO networks. This is a extremely rich space to look at. I think you're going to need to look at which one of those is likely to go first. I will submit that industry is going to go before the MNOs. So if you're looking to actually have implementation, that's the path that you're going to have to take. And you need to look at it from the perspective of the uplink side of the house being met.
Hello, thanks for the opportunity. Myself, Chinmoy Sabut from Capgemini. So basically, there are two aspects I would like to focus for the NOFO 4. So one is we already discussing about the AI in the context of overall the wireless. So there are three concepts: the AI for RAN, AI on RAN, and AI and RAN. So these three aspects are equally important to make it successful. So I think all the tracks are equally important. So if there are different tracks or a combined track, but with a clear-cut objective that, okay, these three principles will be evaluated or promoted, I think that will be one of my asks. And now in the context of exactly the underlying stacks, particularly on this topic, so if you really see, there are three types of the consortium today. One is completely open, one is completely closed, and another is kind of a semi-open. The companies like us who are building, but we are open for certain set of customers, but not really open for others. But each of them has their own beauties and advantages. So I would suggest that, or I would actually look forward to that, how NTIA can create a very collaborative approach across all these players and bring the beauties of these three segments together, and a kind of a synergy between Okudu, AI-RAN Alliance, closed players, and semi-open players, that how they can come together and really drive this movement. Thank you.
Eric Berger, Virginia Tech, actually kind of related, and I'm glad I'm hearing the same message. And it's something that I want to get in the record because it's so obvious. All of these AI-driven changes that we're seeing today are coming about because of Open RAN, because we've well-defined interfaces that enable people to focus on different areas of the stack and across the stack. And it would be so easy for someone to say, oh, I've got the ultimate AI optimization. You just buy my one box. Oh, now it's not one box, my one system, and we're done. So to keep in the solicitation this concept of Open RAN. And then the other is I got into 3GPP because I thought, as an internet guy, wow, this will be the last G. Still working on it.
Hello.
My name is Tarek Randa. I am with PI Works, working as a technology director. We are a company developing closed-loop network automation solutions for the last 15 years for network observability and autonomous network management all around the world. For the 6G technology stack, I think one of the most critical things to have a really good digital twin. Because when we start to talk about AI, there are so many things that we are coming across when we are designing our technologies, unexpected things, and it's very important to create an open ecosystem in United States to bring smaller players to the ecosystem because there are too many smart peoples. They can build some small parts more intelligent than big corporates. And they need data, they need an environment to reinforce their agents, take some actions, see the rewards and penalties, and make some updates. So having such a technology stack, United States has everything from silicon to the software, and these smart people and smaller organizations need some more opportunity, I think. And this NOFO is a good way of funding such an ecosystem. The other thing is, as you know, in the Oran Alliance and now AI Run Alliance, it's all about defining, opening the interfaces to innovate more on the network and bringing some other players. But when we see the selections of the operators, now the early ones are generally going with the platforms are from the same company. We see these in the SMO, in the non-real-time rig. Just the RFs part, of course, there are some marketplaces for the RFs, you can bring something. But the capacity, the pace of overall transformation, which is increasing exponentially in the AI era, is limited to those giant companies' innovation capacity. So the new architecture can be really open with the role of AI, I think, the previous part. I would like to take some speech because, when we are disaggregating the networks, it is hard to bring them together for humans, but maybe not so hard for AI. So AI can have a role of integrating smaller components from different companies. So these can boost the innovation, and these can take United States to a frontier place all around the world, I believe so. Thank you.
Thank you.
So I like this format, by the way, because I don't want to get up here and drone on for 5 minutes or something on a whole bunch of topics, and I think it's great to have this interaction. So in this specific space, and it's important to say, to start off with, standards bodies have a role, and an important role, global interoperability, all those sorts of things. They have also, especially the one that started with a 3, have kind of taken on a life of their own. And they tend to, like they're a living organism, and they want to grow to survive. And so there's a bit of scope creep in there as well. I think Jim brought up the standards development process for 6G is well underway. Over the next few years, it really gets crystallized. But if we look back on 5G, I think we would all agree there was a lot of work that was done on the technology for 5G. That never saw the light of day and never saw a business case behind them. So I think the opportunity here, while we participate in the 6G standards work. There's a lot of great companies here and a lot of great U.S. innovation that's happening that we need to get in there. There's a whole lot of resistance, as you know, as well from some of the larger players. But I think the number one thing that we can do beyond that is to get this inertia going around this U.S. ecosystem here in the 5G and 5G advanced timeline, because a lot of the problems that need to be solved for 6G aren't 6G problems unless 6G is the only way you look at the world, right? How do we distribute, leverage, enable AI through the infrastructure? How do we create a more efficient networking infrastructure to support all of this? Transitioning to software. That all happens now. And so as we get to 6G, there's new waveforms, there's new spectrum, there's new things that come in there, but they're just software upgrades. And people will look and say, okay, the US did this already, and we already have the inertia behind them while everybody else is kind of sitting in the standards bodies and saying, hey, let's look at 6G. So, thanks.
Hi, good morning. Raghunath from MDocs. So we've been working on ARN stack for a couple of months and working with multiple operators around the globe. So one thing is everybody's excited with the AI use case. They believe in the AI use case. But one challenge we see is the adoption to move towards from the use case, from PowerPoint, moving to the lab and the commercial aspect. The one question keep coming up is the cost, right? Like OpenRAN. Everybody like OpenRAN, but the moment you put the stack and the price tag next to it, nobody wants to go to OpenRAN. And other complexity in terms of operations, all those things. Similarly in AI, we see inferencing is the main component. And today what we see, at least from my perspective, what I see is there's not many names when it comes to inferencing, especially the hardware perspective. Is it going towards one vendor lock-in in terms of hardware? Right now in the world, there's not many names in terms of hardware. So this is why we are kind of working with different names to see how we can split that from to be straight like CPU versus GPU, right? For example, who can bring not SLM, but a model that can work for the use case as well, work for the commercial model as well. Because at the end of the day, the dollar amount going to make whether the MNO, especially MNO, right? CapEx, OpEx. So it's not is it going to increase the cost or not? But with AI, we are expecting everything to go down because AI is doing this, adding less people, this and that. So this one area I think we need to see from commercial model. Are we also going to vendor lock-in or going to be open? All these different aspects. Thank you.
Hi, Jen Congdon from Booz Allen. So just kind of listening to some of the remarks from others, as well as reflecting on two of the big conferences that have happened also in this month. Like I think from last week at GTC and the highlight that Jensen had about OpenClaw, for example, and how in like 2 weeks that sucker was out there, right? So I think, you know, Bob, you had talked about it a little. The pace is really fast. Innovation being the first and foremost thing that we focus on. Is probably the most important thing to stay focused on. If you can demonstrate and you can show innovation and get networks out in the hands of people faster, that's going to have more impact potentially faster than standardizing in a traditional sense. I think those things are going to have to converge. And yes, we are going to have some participation in the standards organizations, but hopefully it's going to be more about showcasing what we can do and having a blend of what's here today already with a future proofing, that's a tough term, but a foresight into what we can do so that we don't box ourselves in, but allow flexibility in the standards process as we move forward, because it's just going faster than what any of the other generations were going. So I think we just have to think more about that, that AI is driving changes faster, and you have to catch that innovation or it will outpace us. So we really just have to like push with innovation first, and then drive that consistency, as well as getting as many participants in the ecosystem through the standards process that you can also bring into the mix.
Hi, Durga Sarapathy, Independent. As we look at the AI-driven changes in the telecom industry, there's 2 or 3 topics that keep coming up, and they are the intent-based orchestration or intent-based networking. There's network automation, and then there is agentic AI architectures. I think these are all 3 areas that we should focus on having the innovators strive to make it better. And these, any advancement we make in these 3 areas will go a much longer way beyond 5G advanced, beyond 6G. To Bob's point, we need to leverage all of these things beyond the existing network. So I'll keep it short, that's all. Thank you.
Again, I'm Hariharan Krishnan from General Motors, bringing a end user perspective to this conversation here or discussion here. We see the whole ecosystem, AI distribution in the ecosystem in a different way. We think that the UEs, we see multi-agent systems, whether it's in manufacturing or vehicles on the road, they're all multi-agent systems. There are lots of agents. And these UEs, or the radio units that you put in the car or in the AMRs, have to be more intelligent. And there will be an aspect of AI that is developed just for the end UE radio. We also see there should be a lot of emphasis of AI in the RAN. And we have been talking about edge for a while, but edge is really not an edge. Edge is supposed to be at the edge of the wireless link, but most of it, it's somewhere, we have cloud edge now. So that eats into latency and other aspects. So the way we see is that from a technology point of view, some of the important technology components we think 6G as a package would evolve into is indoor positioning with very high accuracy. A lot of people talked about lack of GPS in indoor. The other set of technologies we think about is using UE's radio information for the network to be more intelligent, especially in handover and other things when the vehicles are driving on the road and they have to be handed over to the best network on the road when there are multiple options. Use more of the UE's, AI intelligence, get feedback and help the UE or the vehicle. We also think that next big thing that we are really interested in integrated sensing and communication, not only because wireless signals with AI can do a lot of, sensing. It can be used for sensing, right? Occupancy or mapping or what have you, right? So we think that is the thing. But from automotive company, especially vehicles on the road, we think that we can get spectrum on the sub 6 gigahertz for this, because the more we go up in the spectrum, you have all sorts of complexities, styling of the vehicle in terms of antenna configuration, dropouts in urban canyons and so on and so forth. So that's how I would see, there will be intelligence, RAN. We really need to have an edge intelligence. Edge should be an edge, not a cloud edge. And then we could do a lot of things with the combination of wireless networks and which are AI driven. Thank you.
Hi, Leland from Gemini again. What I'm hearing from everyone here is we're trying to determine what are we trying to solve here, right? If I was to look at all the phones that I have, they're basically broadband driven devices. I can honestly say that 4G can handle that, and we're fine with that, right? When you look at things relative to 5G, there was more or less I would say a higher data throughput, lower latency. There were massive machine type comms and the like. So did we really achieve that? No, as Tom says, the odds are really kind of setting us up for the evens. So if the evens are now to solve a problem, the way that I see it is, there was mention around reducing OpEx and CapEx. That's attractive to the MNOs, reduce their OpEx and CapEx. So bringing in AI to drive down costs is always a great thing. But for the user experience, a UE is now a different category, right? You can have robots that are now UEs. You can have drones that are now UEs. And I have a couple of drones that are UEs. You can have broadband devices that are kind of working as private network architectures at the edge point. Like you said, there was a mention around the UE, that whole uplink being a bigger part of the connectivity piece. We need to determine what are we trying to solve here. Just saying AI and then placing AI on top of the network, well, what is that doing for us? Is it really an optimization application point? Is it to make the UE experience at the end proliferate that out to be more of a portfolio of UEs that can do more than just open up your phone and look at videos of stuff? Or is the robots and the AI that's kind of physical now going to be driving this whole use case architecture? If you look at things going on in defense, you would say AI RAN is strategically into, I would say, having strong application points at the edge and then driving those different UEs at the edge points and having AI kind of really control those aspects for obvious reasons. But when you look at the consumer endpoint, still trying to see what the consumer sees beyond the phone. Okay, so just want to say, I think a use case driven focus is always key. If we're in the evens and if Tom is right, then right now we need to really define what that is for us.
Hi, good morning. My name is Ku. I work for Keysight. So I work in ORAN Alliance and 3GPP, mainly the plenary, and my colleagues we participate in AI RAN Alliance. So across three organizations, we see that one of the biggest changes that AI is actually bringing to the standards is in terms of testability, right? So for example, today you have Rand4 working on standards for conformance testing of the base station. You basically test the UEs, you got standards testing those as well. The question now becomes when you start to integrate AI into the devices, AI into the radios, AI into the RAN stack, the testability aspects is always left to the end, right? Like we look at, for example, the 6G studies, even for 5G, 5G Advanced, 3GPP in RAN 1 has been working on interface AI for quite some time, but the testability aspects, which is basically stopping adoption and commercial deployments, is not really picking up a lot of momentum at the moment. So I think one thing that the NOFO can potentially do for us, or there are obviously many good things, is in terms of defining the details of what does the training data entails. What are the parameters, the granularity, the training duration, from a use case specific perspective, right? We speak about ISAC with AI-enabled ISAC. What are the benefits, costs, and complexities when you start to look at comparing the performance gains of AI-enabled ISAC with different algorithms, because obviously the algorithms are close, versus the costs and complexities. What are the benchmarking criteria? How do you compare one model is actually better than the other? What do you classify as trustworthy AI? Right? If you test the AI models 10 times, 20 times, do you always get the better performance, or do you actually get a lack of performance? If the performance are basically degrading, how do you explain, right, the degradation in performance? Is it intermittent or is it traceable? So I think a lot of these aspects, I would say, there are many good things happening right now that 3GPP, ORAN Alliance, AI RAN Alliance are basically progressing with use cases. The question really becomes, right, in terms of like, where are the testability aspects? And down to the details of specific information you need to include in the training data sets, the benchmarking data sets, the benchmarking methodology, the KPIs associated for every specific use case, which is of interest to us, which basically includes, as many of us has mentioned, network for AI and AI for networks. Thank you.
Yep, perfect. I was going to come to you, Peter.
Yeah, I've got two comments that came in that relate to this. The first one is from Irfan from the OAI Foundation. AI is based on data and thus requires a large volume of experimentation, diverse data sets before any new technique can be considered to create high enough value to be standardized or adopted universally. Building such experimental tools with easy access to the research and industrial communities is an effort not to be ignored. There are such tools in the communities, such as Shiona, ray tracing, for instance, that help with such experimentation. This NOFO could support some of that work to ensure all AI techniques can be benchmarked. Got another comment that goes to what Ku was just talking about, came from Meghna. Another key area to focus on for AI and telecom, especially as we move towards 6G, is compute and power optimization. As we develop new AI-based solutions, it is important to ensure that they are not only intelligent, but also efficient in terms of resource usage.
Any more final comments on this? This was actually interesting. I think now we're getting into the meat and potatoes of the discussion. If not, then I'll pass it over to you, I guess, Lauriston, for the next one.
Okay. Let's see if there we go. Okay. So as Matthew said, we're getting into the meat now. So the question that we're going to discuss now is the architectural changes required to enable AI in the network. And so here I think we can certainly talk specifically about the mobile communications network, but we can also extrapolate this beyond to other network architectures that are out there, and the question of how AI may bring them into, may align them more in the process. Let's say that. So I am going to open it for questions now. This is the architecture side, guys. So we get to dream a little bit.
Hongwei Zhang from Iowa State. I guess I just want to comment on one dimension of this. I think all of us know about ORAN, right? So ORAN defines different architecture interfaces. And there's one part that has not drawn enough attention. That is how the application, AI application interface with the network, right? If I remember correctly, maybe called Y1 or something like that. I think this is an area that we definitely need more attention, right? Because the network behavior, the use of AI for networking, the actual AI in application, they actually do intersect. So what's the right interface and how to enable that co-design, especially for mission critical applications in factory, agriculture, and other spaces would be very meaningful.
Hello again, Tracy Van Brockel, formerly AT&T for more than a quarter of a century, now WinLab, Rutgers University, and well with AT&T, and operator co-chair of several O-RAN Alliance working groups, focus groups, task groups. I think everybody's familiar with the O-RAN Alliance SMO concept, Service Management Orchestration Framework. So one architectural change is to rethink SMO. It's not just RAN. It never was supposed to be just RAN. That was just a starting point. So if we make it possible for service management orchestration to orchestrate across multiple domains, not just RAN, that would be a big shift. It's kind of happening slowly. It needs a little nudge. And I would like to point out that Ericsson's platform is actually based on contributions within O-RAN Alliance and O-RAN software community with respect to SMO and non-real-time RIC. Thank you.
Again, Hariharan Krishnan, General Motors. There are a lot of experts here from MNOs who knows a lot about architecture than a General Motors engineer. But what I would like to point out here is that in the previous remark, I said UEs have AI component and we have multi-agent systems, whether it's AMRs or vehicles. One thing that I like to see is the network supporting agentic and semantic communication peer-to-peer, so they can decide their actions ad hoc in an ad hoc manner as opposed to having everything centralized through the network. It's not a very popular comment, but I'll just throw it in anyway.
Hi there, everyone. That was the comment that got me to get up. I'm like, ooh, I want to talk about that. I know a lot of faces in the room. I'm Jason Boswell, currently at MITRE. I've been here for about a year and a half now. I lead the infrastructure, networking, and communications division here at MITRE Labs. But many of you know me from my Ericsson days. So been in the active in the O-RAN Alliance and in telecom standards and architecture for almost 30 years now. So a couple of themes I wanted to pick up on. As I said, my division, we run infrastructure, networking, and communications, and I view that as a thread of connectivity throughout the network. And that's how I think about the architecture of the network. It's the cloud infrastructure, that's the foundation, that's connecting information, that's connecting data, right? The network connects systems and systems of systems together. That's how on the routing side we think about networks. And then the communications part is really connecting people, right? So we have to connect information and systems and people. And largely, when you architect a network, the people that are responsible for those three different things are three different groups, right? And hopefully, if you're running things well, those folks like each other and talk to each other, right? But when you think about an AI agent that is looking at, well, how do I operate the network? It's going to think in terms of abstraction. The network is the entirety of the network. It's not just that I want to optimize the compute in a cloud infrastructure layer. If you give AI, especially an agentic AI, the problem and say, I have a human over here and a human over here, and they want to do XYZ more efficiently. It may say, okay, well, you've given me authority to create and modify my own API to allow me to talk to different parts of the telecom stack. So I'm just going to bypass what I perceive as being a slow path in the network and make my own and go around it. And from an orchestration standpoint, talking about the SMO, totally agree. We need to rethink kind of how do we think about the management and orchestration across the entirety of the network. That's exactly what AI is going to enable us to do, is to rethink in more abstract terms about what is typically a fixed discussion. When we talk about architecture, especially us old telecom folks, right? It's A connects to B, and ne'er the twain shall anything else interrupt, right? But we really have to think differently about that. So I heard end to end a lot. You know, the uplink pivot is going to happen. So thinking about in very discrete and precise and prescriptive terms about the architecture, it's going to get left behind. AI is not going to wait for standards. It's not going to wait for 6G, right? The innovation there and the amount of money and funding going into that is going to say, I don't have time to wait for that. I'm just going to build my own way around it. So going back to architecture, and fundamentally, I'm an engineer, and I want to, if I'm, as there was somebody else up here that said, I was an RF engineer, once an engineer, always an engineer. But that's the way we want to think about building that network, is from a predictability standpoint. So the engineers, the humans that are building the network, we need some predictability in, well, how is what I am architecting going to interact with what AI is enabling me to do? And that can either be combative or it can be complementary. So I would encourage in this NOFO that we think about things in an end-to-end world. Think about things like abstract what we think of when we think about a network architecture. It's all of it, and if we give AI access to all of it, what could it really do with it? That can enable us to, you know, think really outside the box, right? So all of those things kind of put together, I think architecture is where that most comes home to roost, because that's when we will be building stuff and making prototypes and trying to move quickly, right? So we have to be sure we're not limiting ourselves with too many fixed guardrails. Over.
Thank you.
Hi, Jen Congdon from Booz Allen. So I think one of the big things from an architectural perspective that we're seeing with AI and AI-RAN specifically is that it's really a continuum. So you've got the cloud and the hyperscalers that have traditionally been in, like, you know, data centers and those kinds of areas, but really we're moving towards how do we start integrating cloud and the hyperscalers into this network, and then look at, you know, with AI Grid, for example, how that's shared infrastructure or shared inference and fine-tuning closer to the edge. But then you also have the edge itself, where those networks can become more impactful at the edge. So I think a little bit of a mind shift of recognizing or seeing that there's a continuum and how to optimally architect the system such that you can recognize the opportunities in each of those and then leverage them up and down or side to side, whichever way you prefer, right? I think that's really important, especially from a compute perspective, because there's efficiencies and benefits to doing the compute at different places in that continuum, and just being smart about doing that is really important. So the other part is that we also need to support access to data to enable AI, with an emphasis really on the E3 interface. And that's really important because it allows you to actually run applications in the RAN itself. So if you're not familiar with it, there's something called DApps that can be that are applications that can be run inside the network, and that E3 interface is really critical from an architectural perspective to enable those types of applications to come to be. So those are, I think, kind of two parts architecturally in order to make that to enable AI in the network: the continuum viewpoint of the architecture, as well as the DApp applications that can be built through that E3 interface. Thanks.
Hi, this is Ku at Keysight again. So I think one thing that came to my mind is digital twin, right? So basically, I think coming from a few perspectives, one is in terms of the ability to get real-time contextual awareness of everything that's actually going on in the network. We talk about physical AI, we talk about, you know, just networks in general. You need to be able to make sure that you know exactly what's actually going on in networks to be able to produce the data that's actually required to train the AI models, to test the models, and to benchmark the models, because otherwise you will not be able to really exercise on making sure that the AI models are being trained correctly, whether this is AI for networks or network for AI. And then the other aspects as well is that when operators are starting to look at deploying AI to their network, they wanted to make sure that it's not always possible to deploy the models to their commercial networks. You will need a virtual environment to use the digital twin as a sandbox environment for testing, right? Looking at the what if, and then see, say, for example, today you have a cluster of like 10 base stations, they're on a different frequency. What if you'll be able to say, I want to add maybe upper 6, right, gigahertz, right, to certain locations, certain bands with maybe 128 TRXs radio. It's not always convenient to deploy a radio out there and start testing in terms of the interferences, the impact to capacities, because this will actually disrupt your commercial operations, and it may not be cost effective and not reproducible. So I think digital twin in that regard will be critical to enable AI. You'll be able to, again, 2 points. One is to be able to construct the physical environment in the digital domain, and to be able to manipulate that digital domain from a multiple perspective and look at realizing the environment that you wanted to be tested. For example, ISAC, right? You can actually have a drone, but then you start to look at using AI to improve, right, the accuracy, detection probability. Then you start to look at training the model in terms of detecting that drone. In terms of accuracy, maybe you take 2 seconds, right, to detect it. Now you make use of AI and you say, okay, if I have the drone at the same altitude and same location, how would that be in terms of applying AI and to be able to make use of digital twin to realize those flight paths and different aspects of it? So yeah, that's it. Thank you.
Okay, Bob Everson with Cisco. My title is actually Chief Architect, so I felt like if I didn't comment on the architectural changes piece, I might lose my job or something here. So, you know, I mean, like, roughly 30 years ago, kind of in the early days, I was a systems engineer actually at Cisco. Just had my 30-year anniversary, and I remember we were in this session and we had all this cool technology and we were all excited about all the things we had and we were trying to put it all together. And then one of the guys just looked and he said, "Well, why don't we take an outside-in perspective?" Oh yeah, you know, that makes perfect sense. Which is, what problems are the customers trying to solve with this technology? What are the problems they solve? And so this drives a use case focus, and this drives a really practical application focus rather than sort of a technology showcase. Yeah. And so I think that that's really essential. When we look at the changes that are happening in the network, obviously to support all of this AI inference and all these AI applications, there's going to need to be a lot of compute in the network. Mm-hmm. But we don't know 100% how to deploy that cost effectively across the network. Mm-hmm. And so people come up with great ideas that say, okay, you know, we're going to have compute at the cell site, and we're going to do inference at the cell site, and we're going to do inference here, and all for it, as long as we can make the economics of it work and the ROI. You know, obviously, as we move to AI RAN, we're going to need some inference at the cell site. Does that extend to user applications at the cell site? Because that's a different level. And then you need a user plane function, and you need these other things to happen out there because you don't have packets unless you have a user plane function. And so all these implications across the network, security, full stack security, all the way from, you know, securing the kernel that the applications are running on top of, all the way to securing the models. We need to be looking across all of that. How do we simplify the end-to-end control plane for these networks? You know, we're going from GTP to SRv6 to, you know, like all these different technologies in there. Is there a way to simplify all of that? And so there are a lot of architectural changes. To me, again, you know, and I'm a little bit of a broken record on this, but we need to get out and deploy these actually in real environments, put this together, and drive that commercial success. Mm-hmm. And I think that's one of the biggest things that the NTIA can help with. And we do that and we look back and we say, okay, we really accomplished this. We're driving success for our U.S. operators, and we have something that's exportable. So, thanks.
Hi, Eric Luther, Software Radio Systems. We are a maintainer for Akudu, one of the technical leads. And I look at this architectural changes and I just keep thinking, this is why Akudu exists. You know, it's a fully open source stack. It's the result of 12 to 15 years of investment already. So you can take this open source project that was just announced, you can attach a radio, and within 30 minutes, you can download, compile, and start making phone calls today to this stack. And then in addition to that, you can inspect every line of code. You can decide where the CU runs, where the DU runs, And so there's never been a better time to be able to break apart this architecture in a fully ORAN compliant open source framework and decide where these things need to run. You can run them on any processor. It's hardware agnostic. And so we're at a moment where we can ask, what does the architecture need to look like? And we can actually make those changes either with the help of AI or for AI. But AI is next. The first thing is you have a fully working open source stack that then allows you to do these architectural explorations. I think we're at a unique position where we can actually do that now, which is pretty exciting.
Thank you.
Eric Berger, Virginia Tech. I'm going to hold my architecture of the business model to, I think that is coming later in the agenda, but I will pull us back. A number of people have mentioned data and access to data. So putting in a plug, the National Science Foundation is sponsoring a workshop. It'll probably be in October here in DC on spectrum data science. Now, that's not the whole thing, but the issues are pretty much the same for everyone. So if you're interested, drop me a note. If you don't have my email address, ask the person to either your right or your left. They probably do have my email address. Thanks.
This is Kalyan again from Keysight. This is a very interesting topic and made me think a little bit more about my past. So one of the first projects I worked on was voice over circuit switch networks. You had circuit switch network and you had packet switch network, which is very different. But it took years for voice over IP to actually come to fruition. I think AI, coming back to present and what we are talking about here, has the power of really combining some of these networks in a big way. Data centers are growing crazy. We don't even have space on the earth anymore. We're trying to put it in the space. No pun intended. But the reality here is there is a lot of infrastructure need. People have talked about compute, but it also should force us to rethink just as being in the RAN space. And we think about SMO, we think about R apps, X apps, and we are kind of living in this world. There is another world that's growing really rapidly with the data centers and orchestration of that and how you maximize the use of infrastructure between the two. AI and RAN experiments have started, but largely AI RAN Alliance is still focused on AI for RAN. AI and RAN is going to start happening. There's a few work items that many of us are involved in. But if you look at it architecturally, we should look at it much bigger than what we are today. And this could be new interfaces, but certainly Tracy pointed to SMO. What is SMO? Is it only for wireless networks? Should it be across the board? Energy efficiency, we've all talked about it. And telcos are going to absolutely love the fact that they can save more energy, but is it just turning on and off cells? Could there be more? What about data center? There's a lot of energy, power requirements and consumption there today. So I think there's just a huge opportunity in front of us. Like we saw in voice over IP, it took a few cycles to get there. I think we should be patient with AI, but it has got the power to unify multiple networks here. Somebody else was pointing about the continuation. I think hyperscalers are now excited. They're jumping back in. They were absent for a little bit. I mean, they were in, they were out because there was not enough, but I think there's more opportunity with compute becoming more and more important across infrastructure. So just my plug is, I think we should think bigger. I think we should try to see how we can, be patient and unify multiple networks here.
Hi, Durga Satpathy again. I think we've heard from the colleagues in this room around what the vision is. We all know what we want. We all know where we want to go. We want this to be agentic AI. We want this to be orchestrated for both RAN and AI workloads. We want automation. We want uplink, downlink flexibility. We want latency where we need it. We also now need to think about where the operators are today, where the enterprises are today, and look at what the challenges are. We have a mix of centralized systems. We have a mix of decentralized systems. Some are open RAN, some are not open RAN. There's challenges in backhaul and transport. There's challenges in just putting a GPU in a center because you don't have power, you don't have space. So anything that we can do from a TCO perspective, I know some of my colleagues talked about it, but that is real. Before we can get the technical architectures, Can there be innovation that would make this more deployable? Maybe is a question that we ask in the NOFO. And of course, I'll keep it short, but in terms of dreaming, we would want to have that AI grid. We would want to have it federated. We want to have it multi-tiered. But to get there, we need to make it deployable cost effectively.
Hello, Raghu from MDocs. So one thing I would like to see from the architecture perspective is that we saw that moving from migration from 4G to 5G, from the hardware perspective, was not too much of change for the operators. I think they just kind of settling down after they make an investment in 5G, right? So now moving to AI-RAN or AI capability, AI-capable network, that's going to be another shift. One from the OEM perspective, maturity of the product or software, that's one aspect. And then one that's ready, they're going to go another cycle of, not migration, I would say, is a complete transformation. Because before was PT from the hardware perspective, you see Ericsson, Nokia, not much change in terms of integrating testing, right? But now moving from that to AI-based network is complete change. So that's going to take time, right? So I think one way to see how we can at least start the process of AI adoption, not from, because this is going to take some time, right? From changing the network. So maybe they should start from the operation aspect. Then while we are introducing AI in the network, the underlying infra, the software and the hardware get mature enough, right? So that by that time, I don't think MNO is ready to make big investment because they just finished all the money, right? Dumb, and they don't see anything yet. And ARN is have a lot of, I would say, promises. We'll see that. Another thing is we have open interface in Open RAN, right? So now, because we are talking to operators quite a bit, and we are almost concluding a POC on AI with one of the operator. So one thing is they like to bring their own models. Can your solution, AI use case, work on any models that we prefer, right? So that means they're opening another thing, not open interface, any open models. That means whatever we build, we're going to go, operator have their own set of thinking or preference, right? Hey, I need to use this. That means whatever you're bringing should be able to adopt to any of the models. So it's kind of changing a little bit from my CUDU should work with this, any RUs. So now my software or your software should work with any of the models that I want you to work with, right? And then I think a lot of people talk about data. I think data is critical. So one of the things that we are able to, because since we work with operators, we are able to get the data. And we do see an impact. When you do in a dev environment, you move to your lab, you might have maybe 5 radios, 6 radios, couple of servers. The moment you plug in the actual data, you see how things are going haywire a bit. But data is key. Thank you.
Hey, Paul Grunwald, ODC again. Everybody's talking about AI really as a kind of a global, there's an AI, right? But I think in a practical application, when you build a network, is you'll have multiple AIs that'll be out there. Some will be pushed out to the edge because whatever they're doing, or whatever that function is, needs to be right at the edge and needs all that power out there. There's some that'll be global, like in the SMO or something like that, that'll do network operations. So really, we're talking about how do you have a hardware architecture and a communications architecture inside your network that will allow multiple AIs to coexist together and run basically in parallel with the network, right? So there's like a whole nother field of discussion that has to happen, which is how much CPU, GPU processing do I need to push out at the edge? And what are those power requirements? What are those costs? How much is at the hotel, which might be a midpoint centralized location? And what do I need to build for there? And then what goes centrally, right? And what goes up in the cloud? And really, if you make those choices incorrectly, some of the new applications for your use cases that you want to push out to the edge, you may have spent your money and you don't have enough space basically left in your servers at the edge. So really, that's got to be a consideration in this as well. Thanks.
Thank you.
Hi, Leland Brown from Capgemini. To kind of beat on Paul's point, if you want to go down to a practical aspect of this, there's kind of three areas to really key in on here. You have disaggregation, function-based in terms of where you place this, and also kind of like a modular open system architecture. So to to Paul's point around compute requirements at the edge and everything, if you can have it where AI now provides us the ability to assign functions at the different, let's say, cell sites, if you will. So instead of having a full stack, depending upon capacity requirements or even frequency aggregation and the like, and I know Eridan has an aggregation radio that does a lot of great things. You can now have it where AI is allowing us, via the orchestration, if you will, to orchestrate the functions of the network that are required in certain areas, right? So instead of having like a full CUDU stack or RU, maybe you may just have an RDU. I think I've seen some of these things, and I think it was at the SRS RAN Summit a couple of months back, where there were some studies around this, where you can now have it where the system can basically, based upon demand, the functional demand, you can now assign what those functional requirements are at that specific point. Kind of makes it more practical. It also, in terms of it's kind of spreading out the functions, where instead of it being a static set, it's more dynamic based upon need sets within the area. I would have loved to have the ability to have my cell towers kind of transform into what I need them to be, as compared to me having to send out a cell tower crew and kind of shift over an antenna, because now I'm seeing capacity over here where I thought it was over here, right? So you can kind of have it where so it's more of a practical aspect as to how you take the architecture and then have it where AI is kind of helping us, ensuring that we're providing those coverage and aspects, you know, where they are required, of course, based upon demand and needs of the network. So, thank you.
Hello again, Tarek Randa, PI Works. I think we are coming to an era that we will start to solve problems that they do not exist for today. And these new architecture, when we start to see after 2030s, this will be on the commercial networks, and we can say it's going to take for 5 to 10 years maybe in our lives. So it should be flexible enough to be expandable and replaceable some parts. If there are some bottlenecks in the architecture, it should be easy to replace. So if we collect everything to a single intelligence layer on top of all the networks, we definitely need this type of orchestrators for the multi-domain orchestration of the things. But we need to always think how we can squeeze the things to the smaller domains for explainability, for security, and for energy efficiency especially. When we look to the change inside the technology, we are always considering the hardware will expand exponentially. We will have infinite resources, and we are designing our architecture and our software solutions in this sense. But maybe some others have some limited resources, and under these limited boundaries, it is forcing them to build some smarter solutions. And this is, in the end of the day, bringing lower latency, lower energy consumption, and smarter solutions in there. So we need to we need to change our mindset to something that we will not have unlimited resources. We need to slow down this belief to think over some smarter solutions. And when we divide the architecture to the multi-tier architecture, multi-tier intelligence, we need to, in the new architecture, we need to design new indicators. We did it for KPIs. I'm using them for the last 20 years. Then we brought it to 5G TQIs. For the AI, we need to introduce maybe key AIs, key AI indicators. If it is making mistake, the accuracy is dropping, the latency is dropping, and we need to bring an explanation, cross-cutting layer, explainability, a cross-cutting layer, which will be observing all the intelligent layers. If something is not doing very well, it needs to be explained to the human level. Because if the things are disaggregated and new user equipments introduced to the network, the complexity will increase. So we need an explanation layer which will explain us. if we kill that, if we do not design this explanation layer, cross-cutting layer from the day one, it will be a one-way ticket. There will be no return. There will be a security issue. You will be relying on AI to understand what is happening. So you cannot intervene. You are killing that button. So to be concise, we need to divide it to the smaller, limited resources, managed controlled way with an explanation layer with multi-tier intelligence layers. I believe in so in the new architecture. Thank you.
Thank you.
Hi, I'm Eric Probsfield from Viavi Solutions, and I'm the director of the Valor program. And actually, I wanted to address the question you have here, but I wanted to actually look at it in reverse and talk about, just for a moment, AI and the impact on the architecture and what this might mean in terms of funding opportunities going forward. So one of the things that we've seen, and I think a few other people have alluded to this, is the idea that the ability to integrate systems and solutions has really been compressed by AI, potentially order of magnitude, right? And so this has really changed our ability to be able to do that. And if you think about that for a moment, you think about what we're looking at funding today, which is primarily wireless, this really allows us to look at incorporating other systems into ISAC, et cetera. But if you think about the funding opportunities that we've proceeded with so far, for example, Kudu, which has been cross-organizational, and the DOT program that we've worked on with you, these they've gotten a lot of positive reinforcement as a result of being cross-functional. It's been viewed as a good use of the government's money and solving multiple agencies' problems. And so to this end, the idea of being able to look at integrating these different platforms and these different systems, I think opens up the opportunity to look at different funding opportunities, maybe not necessarily within this NOFO, but beyond this, to incorporate other agencies in their interests. Thanks.
Hi, Julia Andrusenko, Rampart Communications. We're a small startup in Linthicum Heights. NOFO 2, one of the NOFO 2 recipients. So I understand we're talking about distributed computing platform where we might have RAN and AI workloads being executed in parallel, or AI, helping execute some of those RAN functions. But it's important to remember that adversarial AI still far outperforms the traditional AI models. And I would caution, we need to have security measures because all of these AI models are, I'm preaching to the choir here, can be poisoned and perturbed. So security and trustworthiness of AI models and, black box behavior determination of some of these, proprietary algorithms, these XApps or whatever APIs, you have to check for black box behavior. And my second point was a lot of people touched on resource constraints at the edge. There's a lot of tiny ML models. There's also, you can train well on very small data sets. So it's not just, huge data sets. There's solutions out there for resource constrained environments. Thank you.
Thank you.
Doug Thornton from Battelle. So with AI, we need to remember that 100 gigabits per second is a bottleneck and the speed of light is slow. So our architectures today, when we look at some of the open front halls and things like that, they don't take that into consideration. So as we're thinking about innovating on the architecture, we really need to think about that hardware level. We've seen software eats the world, but free software eats the world. Okudu is going to eat the AI world, but where can we retain a dominance? And that is in that hardware section. And we need to think about how can we encourage the physical hardware growth to support AI.
Thank you.
Peter, I think you've got one online, is that right?
Yeah, we've received several comments on this section, but I'll try and condense it, I think, into two areas that weren't really referenced in the comments thus far. The first one comes from Dora, and I won't even try to pronounce the last name. It's written, as mentioned in some of the previous comments, the introduction of AI ML functions in the network is expected to transform the architecture from end-to-end perspective. One aspect of this transformation is the lifecycle management, both of the machine learning models and the machine learning workloads. Machine learning models, monitoring, training, integration with the rest of the system, and deployment requires a standardization across multiple components in the network to enable operation in an open RAN system. Addressing this gap for implementation is crucial to build a commercially ready AI-enabled 6G network. Received a few comments in this area, and that relates to architectural changes. I'll read one of them. It's from Skylo Technologies. One area where architecture becomes especially important for AI is in supporting a unified terrestrial network and non-terrestrial network designed with an enhanced AI-driven RAN. By embedding AI deeply into the RAN and system design, the network can dynamically optimize across both terrestrial and non-terrestrial. Selecting the best access spectrum transmission strategy, AI models in real time. This approach enables the network to present a seamless and consistent experience to applications and users, effectively making the underlying terrestrial and non-terrestrial infrastructure invisible.
There we go. Okay, great. Thank you. So, as I usually do, I took other people's time and actually got us back on time now. So we spend a little more time, but architecture is certainly our love, and many of these people in this room. So with that, we are about on schedule, and now I'll turn it back over to Brad, right, for the next one? Oh, for Manu for the next one. Thank you.
Okay, so yeah, this has been great so far. I think we've heard a lot about state of the art, where things can move, some of the discussions around architectural changes. This sort of the next session is essentially trying to understand where the gaps are, what are the challenges. I think we've heard some of that, but again, just want to open the aperture from not just, and I think please make your comments writ large, right? So USG writ large, not necessarily just focused on NTI and this NOFO. Obviously, at the outset, the initial remarks were around the AI action plan, the exportable AI stack. So with respect to sort of where the challenges lie, from your vantage points, obviously you're representing the entire ecosystem here. So would love to really understand where some of the challenges that not necessarily just this NOFO, but also broader in the kind of near mid. I'm just making this up real time, right? Like a near, mid, and far strategy with respect to challenges, low-hanging fruits, but something that needs a little bit more of a strategic coordination across USG probably also. So would love to hear your comments on that.
Hongwei Zhang from Iowa State. I want to maybe take agriculture as one example where we truly can and should actually benefit from cross-agency collaboration. Right? So we know AI is the foundation, the driver for future agriculture. And also the agriculture AI requires connectivity to every last acre of the land, which we don't have today, right? So there's actually a lot of needs for us to look at AI of agriculture and then how that's actually interfacing with the AI for the network that's going to support those use cases, I think. So the collaboration goes beyond just technology R&D, right? There's a community building aspect. How do we really bring the two industry together, building mechanisms, platforms, so that they can truly collaborate in ways that's not possible today?
Chaitali Sengupta, CEO of Cirrus 360. So talking about talking about AI leaderships in the context of US, we have seen time and again, software is key. Let's kind of drill down on that a little bit. I was reading this analyst report about NVIDIA last week, and it talks about a software wall. So what do we mean by a software wall there? It's really not just a software-defined system, but everything, if you think, again, just as an analogy, as an example, from CUDA to Dynamo to NIM to NemoClaw, right? So basically, it is a software-defined everything from defining the use case, whether it's a GM use case, an agriculture use case. We do it in a non-ambiguous, formal way, and then we push it through the entire CI/CD pipeline. And that's where we believe at Cirrus 360, we have actually trying this out. We took Okudu, we used our AI reasoning tools to push it to a particular use case in the agriculture space too. But that is where, we believe, and that's where I think the opportunity is for NTIA to push that software wall that goes beyond. Okudu is a great place to start, but then kind of building on top of it and providing that software infrastructure.
Thank you.
Go from MDocs. I think one thing that we see that who is going to be the ultimate play on this is the MNOs, because they're the one going to make the investment and make it happen, end of the day, right? As long they have the ecosystem is proven. So one challenge we see is that they all understand, but I think how NTIA can help them kind of go through the process of journey, right? How they can start this AI journey to show them some proof, some validation points. Of course, there's a key players, only key operators are looking into this and working with, if you see from ARN, SoftBank and TMO, and just very, very few around the world at this point of time, because many, maybe lesson learned from OpenRAN or something, or the cost of it, right? So I think if NTIA can help to kind of initiate workshop to show them how there's many ways to adopt this AI journey. That's one thing. I think when this NOFO will be announced, one of the timeline perspectives, what we see is this, for us to build this, of course, you need inferencing, you need the hardware. So at this point of time, we are making investment and we see challenges in procuring the hardware timeline. So it's pretty significant timeline that you have. So maybe NTIA can partner with whoever will be selected to work with the right vendors to kind of help to meet the timeline. Because I think we need to accelerate this AI-RAN journey quite fast. I think we're not late, but depending on when you're going to digest information and draft and release, things are moving fast. So maybe your help will be a lot helpful in many different ways. Adoption and making it happen. Thank you.
Thank you.
So it's Tracy Van Ruckel, WinLab Rutgers. Just as AI adoption and leadership is very much dependent upon support from standards development organizations, very much dependent upon support from U.S. government policymakers. There are a few recent examples. GCOT's recent statement of 6G principles. See, probably others are familiar with that. The FCC saying, oh yes, mandatory disaster response initiative is now in fact mandatory and requires a rudimentary data model to allow interchange across operators, preserving their autonomy, of course, and that's always a good thing. And previously, a gentleman spoke about explainability, a clear statement of explainability, being able to achieve repeatable results, avoidance of inscrutable algorithms insofar as possible. I mean, we can't pull this off without strong support from U.S. government. NTIA, of course, but not just NTIA.
Eric Berger, Virginia Tech. I am going to touch upon workforce. I'm going to start by noting the United States is, at least right now, the undisputed leader in AI. So that's really good. And I can also tell you that when I'm recruiting students, I have to say that it's an AI project. If I just say it's a telecom project, it's a wireless project, they're like, oh, but it's got AI, great. But then the problem is they go off and work as quantitative traders on mostly crypto assets lately. So where NTIA and the US government could help is that there are interesting jobs at the end of the line, that there is an economy that can hire these people. Yeah, they might not make as much as crypto traders, but it may be more secure. So we've got to think of that whole pipeline, not just all these cool technologies we're throwing out there, but we need the people to create them, we need the people to install them, and we need the people to operate them. Thanks.
Hariharan Krishnan, General Motors. So the previous gentleman said that the U.S. is the absolute leader in AI. I agree. But I'll also make a personal statement. We are not the leaders in 5G, right? So how do we position ourselves as leaders in the next generation telecommunication network evolution? I think one thing is being able to use AI and data to make sure that we are continuously learning from what's happening on the network and being able to change the software, either it's in the RAN or the UE or the edge or whatever it is, being able to do fast adaptations to the software by continuous learning using AI tools. That's going to be key, I think. What should NTIA do? I think NTIA should also focus on, we develop a network, but where is the value proposition of the network and the end user? So look at, are we going to design the best network and don't have any users for it? Or when we have users, does it make sense for putting the United States in the forefront of advancement?
Kalyan K-Site. Recently, this came up. It was a little bit viral, but somebody forwarded this to me. So if you ask ChatGPT this question of, I have to go for a car, take my car for a car wash, and the car wash is 2 minutes away. Should I drive or should I walk? And I'm not kidding. ChatGPT actually said you should walk because it's only 2 minutes, you get exercise, so on. I tried Gemini. Gemini was a little bit better. Now we use ChatGPT for a lot of things. The point I'm trying to make here is that particular thing wasn't trained. Somebody forgot to train this particular AI model saying, well, if you go for a car wash, you always drive because you're taking a car. You cannot walk there. But something as fundamental as this got missed. Coming to AI and how you can bring in telecom, we talked about, how it can, and it is very true. There's a lot of promise. We have seen it in experiments, but for it to be a reality, there needs to be a lot of validation, training, benchmarking, inferencing, so on and so forth, before it can really be put into a live network. So where NTIA can help, like it did in the earlier versions of the NOFO, is making sure A and B can talk, whether it's a RU and a DU, making sure there is some criteria for interoperability. It was funding the Accord labs and so on. So I think it's very important to keep something like that. And second, in NOFO 2, NTIA actually brought up the concept of, are you ready if you're a radio vendor? And many of them are sitting in this room to be deployed in a live network. You need the support of an operator, whether it's a US operator or elsewhere. One of the companies had to be US. It could be a small radio vendor, but it forced some kind of, I hate to use the word standardization, but some kind of a norm. And that was very useful because everybody was marching towards the same thing, and you had to get into MRL5, TRL7, et cetera, et cetera. And that was extremely important. And I think for AI, I think something like that is going to be fundamentally required if we all want to dream of putting it in a live network. We can do experiments, but for it to go into a live network, it needs that kind of validation. And I think this could be standardized, formalized by NTIA. So.
Kyle Allen, Airspan Networks. I think first and foremost, it's investment in the U.S. We can champion wireless innovation in the U.S. by investing in the U.S. and investing in U.S. R&D and investing in U.S. labor sources in the workforce, which many of my colleagues have already said. And so as we write this NOFO, I think that's something that we would encourage, is continuing to invest in the excellent technical capabilities of the workforce here in the U.S. And then second, which has been said maybe too many times already, but just practical application. If we want this to be successful, it needs to result in something that has value, that is sellable to industry, not just MNOs, but also to enterprise, both as potential markets. And I think thinking through that carefully will be a key to the success of driving wireless telecom in the U.S.
Hong Wei Zhang from Iowa State again. I love this topic, so I thought I want to just add one comment and also a call for participation on something related to this. I think, here I think one of the key focuses are about Open RAN, AI RAN, and softwareization, right? One major benefit for that is, for all of this is, I think, it actually provide a mechanism to allow inflow of ideas from different places and also drive the iteration of those ideas, from the early stage fundamental research to field trials and back and forth, right, I think. So now, traditionally, we have different agencies targeting, supporting this different segment of effort in wireless, in AgTech, in other technologies. Now, with all this coming together, I think we have the opportunity to really think about how we can build mechanisms, both technology mechanisms, testbed, living lab, but also funding mechanisms, community building mechanisms to build this ecosystem in a way that can be feasible. So in this respect, I do believe NTIA can play a major role, right? Because if you look at past decades, it has played a major role in service rollout, deployment, operation. With Innovation Fund, we're bringing this kind of innovation drivers to the program. And there are actually many other things that can be done, right? Looking at how FCC may interface NTIA in spectrum, also with maybe defense or CUDA and other effort. So I think this is where I think as folks, think about this NOFO, but also future programs we can look into. Now, with that in mind, I want to also just to share one opportunity for us, for folks interested in this topic, to come together to talk about how we can do this. We're actually organizing an event on August 31st, September 1st. It's going to bring the goal to be bring the ag tech industry, wireless industry together, also agencies together to talk about some of these questions. Thank you.
Thank you. Hi, Durga Sarapathy. I think that's the right goal. How do we advance ours, from a USA leadership? And my comments are around a bit of around process. I think to get there, we first have to know where we are. So how do we do that? You guys are already doing that. You're participating in the SDOs. You're working with the Air Alliance. I think we should do more of that, only so you can get a personal feel for where are we standing in terms of the AI leadership. Once we do that, not listening to analysts, not listening to people saying we're already a leader, but getting a real feel globally, where are we really, right? And once we know we are this, our rank is this, what are they doing that we're not doing? So you do the gap assessment, right? And then look at what are the levers that NTIA has? How can NTIA play a role in getting this gap down to, or minimizing the gap? Is it different spectrum policy or more AI-friendly policy? Is it more spectrum allocation specifically for doing AI and then workloads together? Or is it free GPUs to operators and enterprises? I'll leave it to you. Thank you.
Hi, Jen Congdon from Booz Island. So a couple of items about the leadership part as well as then the challenges part. So I think the first, and I've said this in a couple of the other remarks earlier, but really focusing on a way that you can show off early and publicly is really important, I think, from a leadership perspective, because if we keep it all close hold, it's not going to permeate. We're not going to show strength. We're not going to be, out there in the public. So I think one of the things, and NTI has actually been really great about this from some of the other NOFOs as well, is about having public acknowledgement of the work that's happening. So I think part of that is really important. And one of the things, that Busan's been a part of that has been very public is the AI Win initiative that NVIDIA pushed and sponsored, and we're part of that as well as some other folks that are in the room too. And I think, really, and NVIDIA is really great at pushing us to be public. And as part of that, within 6 months, that group of like-minded American companies really pushed from thought to having a working system out on a show floor operating live, which is terrifying and great at the same time. So I think those types of public displays of demonstrations are really important. I think the other part is, and what was also powerful is that, we didn't stop there. That we also then, and then you can see other folks in the room here that are not necessarily directly a part of AI Win, but we had multiple CUDU companies putting NVIDIA's DGX Spark on a smaller form factor of GPUs and running CUDUs that were AI native, and that was shown off in just the past few weeks, right? So, continuing to show off the capability along as you go, I think is really important in demonstrating leadership. One of the other parts you talked about was linking it to the AI exports program. So I think one of the other things, and we responded to one of the, can't remember exactly what it was called. NTIA. Yeah, exactly. So for the NTIA, the responses of what is this program? How can it help? What are some of the challenges? So I wanted to pull in a couple of those data points because I think they're relevant here. So one, linking it to the exports program in general, I think would be great. Some of it, I think, for us as a technology company and someone who at a company that's been doing a lot of integration, seeing that higher level policy program become something tangible, I think would be really impactful. So seeing that thread pull through in execution, really appealing and really interesting to try. And as part of that, some of the recommendations we put in that is maybe there's a linkage to like a trusted partner program. Someone or companies and a list of companies that through whatever means, maybe this could be one of them, is able to access a list that's like, you have a stamp of approval from the US to start exporting in other places. And so why is that some of that important, I think, globally, or not globally, but broadly? If we want to be an exporter of our technology to other areas, we also have to lower some of the barriers that it comes with doing the paperwork, frankly. So export control can be very onerous. It's very important, but figuring out how to, maybe through a trusted partner list or some other mechanisms of shortening that time and the paperwork scale so that you don't have to do some of the things that are wash, rinse, repeat each time, that this could be maybe an on-ramp to helping facilitate some of that process and showing proof points about how to get there. So that might be one area to consider as part of a linkage to that program, but also helping companies or products and whatever move through that process and using NTIA to help there. So a couple other challenges that we wanted to kind of mention is that data is going to be king. So whether it is having access to training data, which as we start doing more, as I kind of mentioned before, a continuum of, there's a continuum to how this data will work. Some will be housed in MNOs, right? Some of it will be in the cloud. Some of it will be on-prem. Some of it, but having, maybe as part of this program, right, access to that data that more folks can get to, and it's not siloed in those different areas where they own the data, that could be an interesting option to consider. So it breaks open that ecosystem to be able to use a training set of data and have access to it. Some of the other part, is, the hyperscalers and the security part will have, and the cloud part will have challenges with data and security. So embedding that as a important part, showing leadership in security and how you can do it across that continuum, but also, embracing that we need that in this program so that it can flow through with the end product. The last thing I would mention, and we have so many years of experience with this, is FedRamping. That if you want this to be able to be adopted more broadly in government agencies and areas, not just, and it gives a great stamp of approval for public sector and otherwise, FedRamp is still a challenge and it's time consuming. A mechanism that has sponsorship for FedRAMP approval could also be really interesting. So those are some other challenge areas that maybe you guys can help with.
Thank you.
Actually, that was a great comment, and that was exactly my comment, by the way. So Apurva Modi Arunakulas, especially the the data, right? We as a startup company based in Boston, we work with everything. We work with SRS-RAN, we work with OAI, we work with Aerodance RU, we work with Radiusys, we work with Capgemini. We are a NASA program. What is important is that applications are driving innovation, right? So applications are the key as far as artificial intelligence is concerned, and that's the lowest hanging fruit. And one of the things that is a big challenge for us is that use cases, right? So for example, General Motors, they describe an amazing use case. So we don't have the data for that. So having the data and creating some sort of a repository where companies like us can make AI models, because there's so many companies like us in the US, we can make models and we can be really, really amazing and make amazing models so that we can just bypass and leapfrog into the 6G.
Mm-hmm.
So we would love to make AI models, but we would like to have data. So the use case, so we define certain use cases maybe as part of this NOFO, and then we work with maybe folks from the NOFO 1, NOFO 2 who have made the RU, and RU, DUCU, the entire RAN stack, and then use that in particular use case and then define those models or get the data. Because when I talk to big threes, right, it's very, very difficult for us to get any data. They don't give you data. The data is on minute scale. It's not on second scale. It's not on millisecond scale. We actually had to pay Radiusys to expose KPM so that we could get the data much faster, right? So I think that getting the data much faster so that we can build AI models is going to be the key. Thank you.
Eric Probstfield, Viavi. I think one of the things that would really benefit the ecosystem is if we could try and see more focus on the later portion of the technology readiness scale. So for example, if you look at the work that's been done to date, and this is not specific to wireless, it's relatively across the board for government funding, but we have a really strong ecosystem in the U.S. in terms of the early section of the technology readiness scale. So the universities, et cetera, early research is really, really strong. But in terms of being able to get these over the goal line, in terms of being able to get these to TRL 7, 8, this seems to be a real struggle. And so I think from that perspective, anything you guys can do along those lines, I think would be really good. I think some of the things I've seen about what you're headed in the direction for this NOFO, I think is probably a good step. But anything that further along that direction, I think would be beneficial so we can try to see more emphasis here and actually be able to get more of these things actually into the market would be great. Thanks.
So I really just have one word, and it's scale. If we think about some of the painful lessons that we learned from the ORAN days, scale is really important. In helping scale, there's tremendous innovation that's happening here with U.S. players, partnering with a lot of them, and some of them are here, ODC, with Airspan, now with Okudu, a number of others, we work with a lot of these players. But what we learned with ORAN is that scale really matters, and there were some really painful lessons from that. The Chinese vendors obviously have unbelievable scale, and even the Western vendors who are still friendly to us but not U.S. ecosystem have tremendous scale. So for us to be successful, and I think where NTI can really help here, is how do we get to scale and get critical mass around this U.S. ecosystem in the next few years. So that's it. Thanks.
Comes down. Lizzie Paul, I head the Federal Division for Parallel Wireless. I was hoping someone else will bring it up, but here am I. I think the first thing for US AI leadership is broader adoption and ease of use, and at least seeing the difference in using AI versus, 5G came about, but did we as users actually find a difference on our phones or anything? No. So that's the one problem we have to solve across multiple industries, okay? So my focus 22 years, and then now I'm in Parallel Wireless, which is dual use, was on the tactical and defense side and emergency networks. Okay, we spend more than $1 billion, right, trying to get different use cases and applications for the defense side. I was the chair for NSC, right? And a lot of money was spent, multiple people. But is defense really using it now? Is there tactical and emergency guys using it? No. There is an advantage over tactical networks. That's what I worked on for many years. It's higher bandwidth, lower latency, great, okay? So we're getting more data, it's lower latency. But then it's all about speed of decision making, right? It's all about speed and to make your warfighter's life easier. And those two things were not happening, okay? And AI can make that happen, okay? We get the data overload, but you have to quickly make decisions, and AI can do that. You know, filter, get the right information to the right people, could be human on the loop, that's fine. The other thing is things like fast basing, right? If you're not deploying it quickly, making it easier to provision quickly, make it easier for training for whoever's using the UE, and the UE may not be a phone, right, for the soldiers. Is it easy like an Apple phone, right? And AI can help with that. So reduce training. They don't have to go through a manual. If you have to deploy out there on one of the islands, right, make it easy, make it deployable, make it easy to provision, monitor, do predictive maintenance on that. Things like applications where ISR, EW, right, that requires targeting information. Yeah, information overload is galore, but you have to make the right decisions quickly so that you can track and you can target the right one at a precision. And that requires speed, right? Because things are changing. So I think the main thing to do, if we can address some of those challenges across the different industries, whether it's emergency or tactical, which is my passion, but, you know, and make it easier for use and adoption and see that difference in the use case is what is going to make that happen. And AI can be that. Thanks.
Thank you.
Just a suggestion based on the recent RFP that we received from an operator. It's all AI-based requirement they put there. So one of the kind of set apart was they put a section called a scripted demo. Each of the requirement, they ask the vendor or the provider to showcase that in the RFP process. So I think maybe NTIA can look this as an opportunity for both the participant and NTIA, that shortlisted companies should be able to kind of demonstrate their capability in a scripted demo in a short version. And that will allow both sides to see and also opportunity to really show how the solution will be delivered, right? It's kind of, they're very precise, okay, for requirement one, this is my scripted demo that you need to demonstrate. So if something that you can do that as maybe a new way of evaluating these responses, that'd be good for both sides. Thank you.
Thank you.
Perfect, Fang. Before I get to you, Peter, anything?
Yeah, we've got a few. Do you want to take his?
Yeah, sure.
Just because one just came in and I want to go through it and then.
Just one comment about related to some of the earlier discussion. I think to drive the progress, right, I think we need a lot of investment at the base station, core, GNOB, and so on. But there's actually the UE side that we have not paid enough attention to, right? Especially on the open source side. I think yes, we have Okudu that's really going to help a lot on the GNOB side, but I think the UE, that's where the domains like public safety, defense, agriculture, other private sectors is going to benefit a lot, like Sidelink and other innovations. Thank you.
I can't let Hung Wei keep mentioning agriculture without putting in some more plugs. So Amanda, you talked about a revolution rather than evolution. So with agriculture in mind, and Hung Wei is my newest best friend in the whole wide world. So we think that leadership really is going to come when we move kind of past network optimization to outcome optimization. And obviously, we're a bit biased, but we believe agriculture represents a very, very good vertical market, and the vertical markets and those use cases have been talked about here and referenced. So optimizing outcomes. In ag, it's really about a full end-to-end, full stack, vertically integrated solution, and we see AI as being really that conduit to create that vehicle. Is NTIA considering a structure that takes a full stack approach and looks and incentivizes vertical integration and very specifically scalable deployments, field deployments? Thank you.
Thank you.
All right. I'm going to read to you two that I don't think were touched on in comments made up until this point. The first one comes from Aliet Erickson. This NOFO could be a great opportunity to confirm the position of mobile networks as the central nervous system of the AI stack. AI is not only dominating the commercial space, but also the technology, policy, and funding space. Telco risks being sidelined, viewed as a necessary enabler for the AI stack, but not a key core component. We would like the NOFO to emphasize the role of mobile networks in connecting AI to the real world. Mobile networks provide differentiated connectivity for AI consumption on smartphones and other devices, secure compute enclaves at the edge for AI payloads, authentication for data collected from connected devices, etc. Received another comment from Dell. From our perspective, supporting demonstrations of AI native RAN in private networks and industrial settings, defense, public safety, logistics, manufacturing, and energy, these environments offer controlled, instrumented proving grounds where AI-driven RAN optimization, interference management, predictive scheduling, URLLC, adaptive resource allocation can be rigorously measured against real operational KPIs, not just lab benchmarks. Importantly, private network deployments are where U.S. companies can collaborate to validate multi-vendor AI RAN solutions end-to-end, proving that open, interoperable architectures built from components by multiple U.S. and allied vendors actually deliver at the performance and reliability levels industrial operators require. This multi-vendor validation by trusted American partners is what gives the exportable stack credibility. Allied nations investing in industrial 5G across Europe, Indo-Pacific, and beyond need confidence that an AI-native solution works across vendor boundaries before they adopt it. A NOFO that funds these integrated vertical-focused demonstrations produces both a validated U.S. technology stack and the proof points allied buyers need to choose it over non-trusted alternatives.
Thanks, Peter. So we'll move on. We're a couple minutes, but I think the good news is some of the last comments actually tie into the last part, which is, yep, Brad's going to take that next one.
Okay, here we go. This is the last one, so your last opportunity to make your voice heard. The topic is leveraging artificial intelligence to monetize wireless telecom network data and unlocking participation from traditional and non-traditional network players through data sharing frameworks. There's a lot there, but we'd be interested in your thoughts.
Okay. So I met with an accountant recently, and he said, if you just give me more money, I can make you more money. And I want to be sure that we are thinking about not just the more is more aspect of innovation, but also can less be more. AI is a very data hungry and data centric innovative technology, right? But we've heard a lot of that. If we just had more access to data and more data and more data and more data, but somebody brought it up earlier about the optimization of where do we put compute. It can't just be more compute in more places, getting more data to optimize this much, right? We need to look at also, are there models where we look at, maybe rural America, not just the macro cells. If we can optimize more efficiently with less information and using more inference at the edge, I think back to like early Cisco days with NetFlow models where like sampling, we realized, 95% is pretty good. And we can just take samples. One every 100 packets, we can take samples, infer a lot, and predictive analytics like changed the game. We realized we didn't have to do deep inspection of every single packet, much like we don't have to know the explicit data point of every single model. If we can get the inference and output, what can we do with that? So that goes to the data sharing framework. If we don't share that, then we end up building these very expensive silos at every single point. So think about, that's one of my comments today is don't just think about more is more. How can less be more too? Thank you.
Eric Berger, Virginia Tech, and this is a case where not every problem is a technology problem, as I have some former FCC colleagues here. Right now, a lot of the data we're talking about, it is illegal to collect and it is illegal to use. It would be probably worth for NTIA to help the community look into how can we create pathways and guideways, either to figure out how we can share. I know NTIA can't do this directly, but if you create the information that then maybe we could go to, say, Congress, if it requires a base law change, or to the FCC, if it's a regulatory change. But we first need to figure out, what are the policies that will enable this sharing to happen? Thanks.
Yeah, Hariharan Krishnan, General Motors. So the first line of this statement here is very interesting because it talks about leveraging AI. And AI works best if there's a lot of data, right? We all know, otherwise it's going to give you bad answers. Mm-hmm. It's always difficult, the second part of the first sentence, which is how do you monetize wireless telecommunication data? It's hard to get it, especially from public MNOs, right? I mean, public network operators. So there was a question on the call which says, should the emphasis in the near term for this NOFO focus on private 6G networks and AI-driven RAN? And I think I have to agree with that, because if we leverage AI RAN and private networks to either in manufacturing or agriculture or in defense to do leverage it properly and put it to use, that data, because the users don't have really a lot of advantage in network data, they can make it open source. There are a lot of universities here who can learn from that large data and create AI solutions that are better and make it more affordable and deployable. So I'm not saying, so can we focus initially on private 5G networks, learn from there, and then go to the public network area where the learnings can be applied? Because the data is more restricted when you go public.
Mm-hmm. Hi, good morning. I'm Charles Cockrell. I'm with Virginia Tech Applied Research Corporation. I'm a little new to this community, as just started this role, but when you talk about traditional and non-traditional network players, what came to my mind, I spent 35 years at NASA, and I think about all the things that are happening in space communications, and a couple people have mentioned terrestrial and non-terrestrial networks and other systems. This, to me, sort of goes to that point, right, when we think about leveraging AI, the tremendous number of assets that we are going to have in space in the future. When I think through satellite systems and distributed networks, but also this week I read Blue Origin has filed to put 50,000 data centers in space. StarCloud wants 80,000. It's not just so AI-driven networks to figure out the integration and optimization of those systems. So you've got communication, computing, data analytics, all of those things. But we think about being able to take that data and monetize it for traditional sources. There's all kinds of things you could do in the public domain, and particularly with U.S. leadership for things that we need in the public sector. And I think food security, land use, sea rise, understanding all of those applications. There's a tremendous optimization problem in there. So one of the things that comes to mind maybe is to figure out a use case where we could talk about integration of networks, how all of that happens. And then Eric mentioned on the policy side, well, what things do we need to do to make sure to connect the dots going forward? I would love to see someone help think about that from a public and private sector integration standpoint so we could think through the right things to do. Thanks.
He said a lot of what I wanted to say, but just a quick recap. Monetizing 6G is a bidirectional problem. We need somehow the network to become more aware of the physical world more aware of the network. That necessitates new integration points. Obviously, there's data involved. Food security was an excellent example. And I just read a paper about knowledge assembly systems. And of course, I've worked on a project with artificial intelligence planning to integrate the network with either a military mission or a problem in the physical world. And again, necessitates strong support from policymakers. Thank you.
Thank you.
Most dangerous place in the world is between me and an open mic. So George Woodward, CEO, Trilogy Networks. There's so much that I could say about this. I mean, we're a sales organization at heart, pretending to be a technology and solutions provider. But leveraging AI, monetizing wireless data, non-traditional players, broken record, agriculture farmers have probably hold more data than any other single entity or enterprise segment. That data could be unlocked to create massive change in the world and specifically assist in U.S. AI leadership, U.S. AI food security, and food dominance as the provider of quality food for the world. We've got that non-traditional and unlocking, and it really requires a lot of time at the microphone and some really well thought out things. I don't have any of those. I'm not going to take the time. I don't have the pithy thoughts. I do want to make a plug for growers, and if we unlock data and the growers are the beneficiary of that unlocked data, there's almost untold monetization opportunities. The food, agri-food industry in the U.S. alone, just in the U.S., is $1.5 trillion annual reoccurring. That comes from 2.1 million farms, and I mentioned earlier representing 900 million acres of farm and ranch land that we need to deploy AI solutions across. There's 570 million growers across the globe. We really do believe that one real solid path to AI leadership is through agriculture, through food security, dominance, and unlocking that data at the benefit of the growers. Thanks.
Thank you.
Peter, do we have anything?
We do. We have a comment that came in from Viavi Solutions. And they state, I see AI-driven network data monetization as a key lever to unlock new value across the telecom ecosystem. A sovereign AI approach where NTIA governs secure, compliant storage and controlled access to telecom data can ensure national interest, privacy, and trust are maintained while enabling broader ecosystem participation. By standardizing data sharing frameworks and enabling policy-driven access, NTIA can catalyze innovation while retaining strategic control over critical network intelligence.
Okay, very good. Any others on this topic in the room?
Yeah, I just want to throw out one more quick thought. Think back specifically to like what government can do to help recently. So at MITRE, we've seen a lot of interest and reinvestment through investment dollars done in research entities and FFRDCs. such as via MITRE and similar national labs. But looking at the what DOW R&E has done with the patent holiday, I think we're starting to see a lot of success there. So looking at free evaluation, no cost licensing, like for a 2-year program, to take areas where government has invested, there are patents that can be exposed, and then it's kind of almost like a try before you invest type of model with patent holidays. I think that's an area where the government could continue to lean in that space. Thank you.
And actually, from Jason's original comment, the statement more data is better, there are cases where that's not true. There are a number of scenarios that we've run where actually the more data you throw at something, the larger the models are, the worse they perform. That some of like the single-digit billion models do way better and cost a lot less. So again, that's an area that we ought to be thinking about. It still doesn't change us because I still want to be able to share data, right? But just to kind of get that, we have to become China, and all of your data is ours is not going to be our answer.
Right.
Thanks.
Except for when it comes to agriculture. I'm not going to talk about agriculture. Hongwei Zhang from Iowa State again. So I just want to highlight maybe something that more or less obvious, right? I think besides data sharing, we do want to also look at model sharing. Especially those foundational models for models tackling some of the kind of lower level modules that can actually help address some of the data privacy and related questions. Thank you.
Okay. Tarek Kranda, PI Works. One of the important things that will help us to develop more advanced AI models is the documenting down the tacit knowledge, where Satya Nadella was talking about in his Davos speak as well. Data is over there. We are collecting the data from the networks and storing them for last 10 years. We can make good forecast of the next 2 years by using the KPIs on the network. Short-term and long-term forecasting algorithms are already enabled on the networks. We are using them in our company for predictive energy saving, predictive load balancing, capacity management, etc. already. But the main segregation topic between the intelligence of the algorithm is the know-how inside the organizations. So when we are developing the agents, we are trying to model and document down the tacit knowledge. And this tacit knowledge sometimes requires multi-domain experts to come together. So at this point, the leveraging and unveiling this information and bringing organizations together to make a better understanding of the networks with the experts from multi-domain, from multiple companies, multiple organizations, can be critical to build more intelligent solutions comparing to the to keep the leadership of the United States in the telecommunications sector as well. This is the topic that I would like to share.
Thank you.
Hi, this is Ku at Keysight. So we speak a lot about data. I think, I believe the NOFO would address this. But I think if we select, some use cases that we deem as a valuable AI, right? The AI which is basically, worth, investing. We got to look at defining as outcome the definition of the data. What do we define data? Before you share data, it's like, data is almost everything, right? But, specific to the use cases, what kind of data would be useful in terms of dimensions, the granularity, and data would change over time in terms of the context. For example, there's been quite a few demonstrations in terms of robotics and the ability to be able to offload certain processing from, the robots to the edge. Now the question becomes, yes, to depend on the state of the connectivity to the robots and what's actually, for example, the battery, like the computing resources, which are basically available on the robots. So I think if we basically select a few use cases and then drill down into the details and start to define, right, for this use case to be possible, what kind of data will be required, down to the level of details that we need to be able to replicate this scenario across multiple places, not just in terms of the one-shot demonstration, but to be able to scale the ability and say, okay, now even if the data are basically restricted to certain deployments, for example, General Motors or other car manufacturers, but for each one of them, if they basically have access, right, to this level of details, they will be able to scale independently, right, without even having to share data, across multiple networks. I think this is one way to be able to look at scaling the entire ecosystem. If you can try to get down to the details of specifying what kind of data will be required, line up with the use cases, and then expanding to that, bring on to my earlier point in terms of digital twin. In one case, you'll be able to look at collecting high resolution maps around a factory floor, maybe multiple factory floors. But the question becomes, there's always going to be changes, right? There's always going to be new robots getting made. There's going to be expansion. There's going to be different focuses. The question now becomes, as we start to having multiple kind of deployments, you would actually probably need a digital twin to be able to say, okay, now this is an instance of the digital twin that you capture a manufacturing floor. But what if I need to be able to generate data for another kind of factory configuration? Do you try to anticipate what potentially could be there? You build it first physically, you collect data, then you generate the data, or would you want a digital twin that's actually being built based on prior data created, and then to anticipate what potentially could be the deployment scenarios and generate data based on those, and then to be able to look at simulating before you get actual device under test, right, or deployed to be able to realize that scenario. Just a few points for considerations. Thank you.
Thank you.
Just one, two, or three quick questions. How will NTIA tie AI RAN funding to measurable economic outcomes, not just network performance? Question one. Question two, how can NTIA enable trusted data sharing so that non-traditional players can participate in the economics of AI and AI RAN networks? And then the last one is, what specific actions can NTIA take to move AI RAN from pilots to scalable deployments? Thank you.
Okay. With that having been said, Amanda, we hand it back off to you, or do you have any more?
Okay.
We hand it back.
Yeah. Okay. Well, thank you all very much. I'm overwhelmed by the volume of participation and the comments that we received today. I think it was exceptionally valuable to me and the entire team here. So thank you all for providing your inputs. So after today, we are going to post this session online. It will probably be in multiple components because it was quite long, but you will have access to this data. We at NTIA are going to take everything we heard today, compile it, consider it, and build a NOFO that we hope is responsive to everything we heard today. And we hope that very shortly after this, we can post the NOFO. You can take a look, and then we can get together again soon to talk about the details of that funding opportunity. So thank you again. Appreciate everyone's input, and have a great day, and good luck on the next NOFO.
Is that?